talk about the graphs of cosine and sine. Here we're going to talk about the graph of sine. The trig functions can be graphed in a rectangular coordinate system by simply plotting points whose coordinates satisfy the function. Thus, we graph the function y equals sine x by listing some points on the graph, and because the period of the sine function is 2 pi, we actually only have to use the interval 0 to 2 pi. The rest of the graph is made up of repetitions of this period. Again, the idea of a period is when values of the trig function regularly repeat themselves. We say that the function is periodic, and the values of the sine function actually repeat themselves every 2 pi, or after every whole rotation around the circle. Amplitude. The amplitude is the maximum displacement, or maximum value, I should say, of the function, and the value of the amplitude is the absolute value of A. A is the number that comes right in front of the sine function when we write it out. And if the value of the absolute value, if the absolute value of A is greater than 1, then the curve is stretched, and if it's less than 1, then the curve is shrunk. The amplitude is half the distance between the maximum and minimum values in your function, and will be the absolute value of A, since distance is always positive. So what I've done for you is I've just simply looked at, okay, well, for sine x, if I let x be 0, that's sine of 0. Sine of 0 degrees, remember for unit circle, sine is y. So for the 0 degrees or 0 radian, my y value is 0. For pi over 6, or sine of pi over 6, the y value is a half. So I have a half. At pi over 3, the y value, radical 3 over 2, radical 3 over 2. And so what I've done is I've just basically written out some points for you and given their given the values of y that go with them, because ordered pairs are always x, y. Okay, one thing to note, and we'll get back to these points here in just a moment. One thing to note is in plotting these points, we use approximations. For example, instead of square root of 3 over 2, we use 0.87. And instead of approximating pi, we'll mark off the x-axis in terms of pi. So what we do then is we understand that for the unit circle, the sine function, which is the values of y, has a max value of 1 and a min value of negative 1. Just simply the values of y. Now, if I go and I look at the points that we came up with, and I take my x-axis here, and I mark it off in terms of pi, 0 pi, pi over 2 pi, 3 pi over 2, 2 pi, 3 pi, 4 pi, right? If I mark it off in terms of pi, I can mark the coordinating points that go with it. For example, at 0, I have 0. So there's my point. At pi over 2, I have a height of 1. At pi, I'm at 0. At 2 pi, I'm at 0. Oops, skip 1. 3 pi over 2, I'm at negative 1. Now, notice that sine waves, or sinusoidal waves, or basically the idea is that it's a wave, okay? Waves have a top and they have a bottom. So for example here, connecting your dots in smooth curved motions, I have a whole top wave, a whole bottom wave. So this is one cycle, one top, one bottom, one cycle of the period, of the sine function. The period of the sine function is 2 pi, which means that a complete wave, a complete cycle, a complete top and bottom will be made in length from 0 to 2 pi. This curve just keeps going. It just keeps going, okay? For example, I can extend out, well, okay. I can extend out by just following. Just basically reproduce this same shape again on both sides. So over here I could reproduce the same shape. Oops. And it keeps going. This is the sine wave. It's a wave. Okay, and so this is what we have. So let me show you. Here's what we have. Now we just connect the dots. All right, now again the period goes from 0 to 2 pi. One period, one cycle. It can go from 0 to positive 2 pi or 0 to negative 2 pi. The period is 2 pi, which means that one top, one bottom will complete itself in length 2 pi. The amplitude is the it came out wrong, sorry. The amplitude is from the height. It's basically, okay, the amplitude is the distance, the half of the distance between your max and min. My max is a height of 1, my min is a height of negative 1. So we have here from 0 to 1 is distance 1, therefore this is my amplitude. Amplitude value, now again remember I was graphing the value of sine. Amplitude or value of A is the number right here. I don't have anything in front of my sine, which means A is 1, which means the absolute value of A is also 1. A couple of things to note about the function. The range is from negative 1 to 1, i.e. the amplitude. Domain is negative infinity to positive infinity. The domain is the value of all angles for which the sine function can take. The sine can take on any angle value. The period is 2 pi. Graph's pattern repeats itself in length 2 pi. The function is odd, and we can see this by noting that it is actually symmetric with respect to the origin. Okay. Let's look at a couple of examples here. It says when wanting to graph variations of the sine function, it's helpful if we notice key points. A couple of things to notice. Key points, for example, here are my key points, and what I'm going to do is I'm going to make away from these key points. Okay, now, there are how many x-intercepts? 1, 2, 3 x-intercepts. How many maximum points? 1. How many minimum points? 1. That means there's 3, 4, 5 key points. It says one complete cycle of the sine includes 3 x-intercepts, 1 max, 1 min. The x-intercepts are the beginning, the middle, and the end of the cycle. Beginning, the middle, and the end of the cycle. The max takes place at 1/4 of the way through the cycle. It says the curve reaches its maximum point 1/4 of the way through the cycle. Because if this is 1/4, this is 2/4, this is 3/4, this is 4/4. Okay, so that the max hits it at 1/4 of the way through. The minimum hits it at 1, 2, 3 of the way, 3 ways through, right? So 3/4 of the way through the cycle. Thus, the key points in graphing the sine function are attained by dividing the period into 4 equal parts or quarters: 1/4, 2/4, 3/4, 4/4. So this is what we have. x1, the value where the cycle begins. x2 is the distance. Take your first point and add your period divided by 4, basically your quarter length. For the third point, take the one before it, add the quarter length. For the fourth point, add the one before it and your quarter length. For the fifth point, take the one before it and add your quarter length. So this is what we're going to do in order to find consecutive points for our function. Okay. So, in graphing variations of the sine function, first you identify the amplitude and the period of the function we're talking about. Next, find the x values for the 5 key points. That means you have to find your quarter length. Next, find the y value for each of your 5 key points. Next, connect the 5 points with a smooth curve. And lastly, extend if need be. Let's look at an example. So first things first, we want to find the absolute value of a. Remember, the equation is y equals a sine x. So the value of a here is a half. So if I want the absolute value of a, I want the absolute value of a half, which is 1/2. This means that the max and min values occur when y equals plus minus a half. The period. For the sine function, the period is 2 pi. The quarter length is to take your period and divide it by 4. So that means I'm going to take my 2 pi, divide it by 4, simplify pi over 2. Find the x-coordinates. Start where cycle begins. We're going to start with x1 being 0. We're going to start with x1 being 0 for right now. We'll talk about how that might change in a moment. Start with x1 being 0. That means that x2 is x1 plus your quarter length. That means that this is 0 plus pi over 2, or just pi over 2. x3 is the one before it plus its quarter length, which means it's pi over 2 plus pi over 2, or 2 pi over 2, which will give you pi. The fourth point is the one before it plus its quarter length, so it's pi plus pi over 2, which will give you 3 pi over 2. The last key point, because there's only 5 of them, is the one before it plus the quarter length, which will give you 3 pi over 2 plus pi over 2, which will give you 4 pi over 2, or 2 pi. Next, we have to find the y values for the x-coordinates, which means we have to produce a table of values. For a table of values, we have our x, we have our y equals the function, and then we have our ordered pairs. My x values are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Plugging this in, I have 1/2 sine of 0. That's 1/2. Sine of 0 means what's the y at 0? At 0, the y is 0. So I have 1/2 times 0, or 0, ordered pair, 0, 0. Next, I have 1/2 sine pi over 2, which means 1/2 times. Sine of pi over 2 means what's the y at pi over 2? The y is 1. So I have 1/2 times 1, which is a half. Ordered pair, pi over 2, 1/2. Next I have 1/2 sine pi. That's 1/2 Sine of pi means what's the y at pi. At pi, y is 0. Ordered pair, pi 0. I have 1/2 sine of 3 pi over 2, which will give you 1/2 times the sine of 3 pi over 2 means what's the y at 3 pi over 2? It's -1. So that'll get you -1/2. Ordered pair, 3 pi over 2, -1/2. Lastly, 1/2. Sine of 2 pi, that's 1/2. Sine of 2 pi means what's the y at 2 pi? That's going to be 0. Ordered pair, 2 pi 0. Next step is just to graph the function using the points that we came up with. So my x values were 0, pi over 2, pi, 3 pi over 2, and 2 pi. I had an ordered pair of 0, 0. Pi over 2 was 1/2. Pi was 0. 3 pi over 2 was 1/2. And 2 pi was 0. Lastly, just continue your curve. Connect your dots with a smooth curve. And there we've graphed y equals 1/2 sine x. Let's do another one. This time, let's graph -2 sine of x. Okay, first I want to talk, again, this is y equals a sine x. So I want to talk about the absolute value of a. The absolute value of a will be the absolute value of -2, which is going to be +2. Meaning the max and min occur at y values plus and minus 2. The period of the sine function is 2 pi. The quarter length is your period divided into 4. So 2 pi divided by 4, or pi over 2. The x coordinates, we're going to start with x1 being 0, x2 being the point before it, plus your quarter length, x3 being the one before it, plus your quarter length, x4 being the one before it, plus your quarter length, x5 being the one before it, plus your quarter length. Last, we want to find our y values for these, which means we want to use a table of values. We have our x values, our evaluate, and then we have our ordered pairs. X values we came up with were 0, pi over 2, pi, 3 pi over 2, and 2 pi. To evaluate, I have -2 sine of 0, which is -2 times 0, ordered pair. Next, I have -2 sine of pi over 2, that's -2 times 1. So I have pi over 2 and -2. Next, I have -2 sine of pi, -2 times 0. So I have pi and 0. Next I have -2 sine of 3 pi over 2. That's -2, -1. Ordered pair, 3 pi over 2 and 2. Lastly, negative 2 sine of 2 pi. That's negative 2 and 0. Ordered pair, 2 pi and 0. I know I did this a little quick, but all I'm doing is every time I'm looking for a piece, sine of 0, I'm noting my unit circle. So sine of 0 is 0 for the y. At pi over 2, sine is 1. At sine, or pi, it's 0. At 3 pi over 2, negative 1. And at 2 pi, it's 0 again. So that's where I've gotten all of our values here, using the unit circle like we did in the last example. All we're going to do now is we're going to graph our function, but notice what this says. It says extend, basically go from negative pi to 3 pi. Alright, so we're going to graph our function. Oops. So I have 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, negative pi over 2, negative pi. Okay, now. Alright. Now you might be asking, well, how did you get from here to here? How did you know that this was 5 pi over 2? Well, because between here and here is the length, quarter length. Between here and here is quarter length. So all I did to get the next values was I took 2 pi and I added pi over 2. I took 5 pi over 2 and added pi over 2. Same thing on the other side, except this is negative of what's on this side. Since I know I need to go from negative pi to 3 pi, here's negative pi. I'm going to go all the way out from negative pi to 3 pi. So those are the only ticks that I need on the x-axis. Ordered pairs, I had 0, 0. At pi over 2, I have a negative. At pi, I have 0. At 3 pi over 2, I have 2. At 2 pi, I have 0. This basically mirrors itself, which means that I'm falling down. So 5 pi over 2 will be down here at negative. Scoot back up. 3 pi will be at 0. Coming over here, negative pi over 2 will be at 2, and negative pi will be at 0. Go ahead and connect our dots. Okay, so there is my wave. One thing I would like you to notice, and again, this equation that we just graphed was y equals negative 2 sine x. One thing I'd like you to notice is that the amplitude of this obviously was larger. From the x-axis to its max, from the x-axis to its min, it had a distance of 2. So, for example, this is your amplitude. So obviously it was larger than the last example. But one other thing I want you to notice is that from your y-axis, the start of your curve for this one dropped down. From left to right, dropped down to start. How would I have known that from the beginning of the equation? Right there. Started with a negative. Now if I go back to the problem that we just did, notice that this one, from the x-axis, started up. How did I know that this function would start up? Right there. Because it's positive. So those are just a couple of things that you can kind of notice with the equation of sine. And we'll get into more relationships between the equation and the graph in the next section.